For this trig sub problem, I don't have a cheat sheet. I'm flying by the seat of my pants here. So let's see if we can't solve this working together. I've got x squared times the square root of x squared minus 25. So that's pretty transparently going to be archetype number 3. So what we got to do is let's construct a triangle. Let's use our substitutions. And for our purposes, we are going to assume that we are dealing in the positive case where the x value is greater than that a value. But we could do it the other way if we needed to. So I need to get x squared, or square root of x squared times, or sorry, x squared times the square root of x squared minus 25. So let's draw us a triangle. So I've got x. A is pretty easily understood to be 5 here. And then x squared minus 25. That gives us that x is 5 secant theta. So dx becomes 5 secant theta tangent theta d theta. And then this quantity here, square root of x squared minus 25, is 5 tangent theta. Okay. So now we have all the pieces. Let's plug them in. We go here, we say, okay, that's the integral 5 secant theta squared 5 tangent theta and 5 secant theta tangent theta d theta. Okay, so this is not going to be fun. You may not know why yet, but I sure do. And we're going to have this here. So we have 5 secant theta squared, 5 tangent theta, 5 here. So I've got 4 5s. So that's 5, 25, 125, 625. So I've got tangent squared theta, secant squared theta, tangent squared theta, d theta. So I've got to kind of remember my techniques here. We can't use a substitution of u equals secant because u equals secant of theta gives us the u equals secant of theta will give us secant tangent, but we have a tangent squared, not a secant tangent, so we can't just use that. So instead, what we're going to have to do is use a some identities here. 625. So tangent squared theta is what? It's secant squared theta minus 1. d theta. So then that's going to split into 2 integrals. So here's the thing. Secant to the 5th theta and secant cubed theta are nasty. You probably don't actually have enough board space to do it. But we're going to get started. If we don't finish, that's fine. You can go back and refer to what we did. So I know that we've covered secant cubed theta in a previous video. So that one I'm not that worried about. But we haven't covered secant to the 5th theta. So let's try to see if we can figure out what we would do with secant to the 5th theta. So we're not going to worry about the 625 for now. We're just going to worry about that secant to the 5th theta. So let's kind of go in an opposite direction. I'm going to take a red marker. So if you're doing this, what you're going to want to do is you're going to want to do an integration by parts. You're going to want to take one of those secants off. You're going to say, actually you're going to want to take two of those secants off. You're going to want to say, all right, that's secant cubed theta, secant squared theta d theta. And then you're going to take this to be your dv and that to be your u. So du is going to be 3 secant cubed theta tangent theta d theta. Man, I hope you can read that. That looks really light to me. Let me try to get a different red marker. And then, that's a lot better, right? So then V is going to be tangent theta. So that at this point we end up with, remember it's UV, so secant cubed theta tangent theta minus V du. So this is 3 secant cubed theta tangent squared theta d theta. So at this point, what we can do is we can convert this again. We can say, all right, that's equal to secant cubed theta tangent theta minus 3 secant cubed theta secant squared theta minus 1 d theta. Again, this is all secant to the 5th theta d theta. So this red marker is already running out, it looks like, again. So now we have secant cubed theta tangent theta minus 3 secant to the 5th theta d theta plus 3 secant cubed theta d theta. So now I have 3 of these over here and 1 of them over here. Secant that. So what I would do is I would add this over. So I end up with 4 secant to the 5th theta d theta is secant cubed theta tangent theta plus 3 secant cubed theta d theta. But I don't want 4, I want 1 of them, so I just divide everything by 4. So that becomes 1/4, becomes 3/4. Now again, we're not really out of the woods yet because we still have to solve that secant cubed theta. So again, I don't have secant cubed theta off the top of my head. I know that it would be an additional integration by parts. So you would have to solve what secant cubed theta is by integration by parts, and I just don't remember that off the top of my head. But let's just, so those pieces, so this secant cubed, which is actually a part of just this piece alone, and then this secant cubed, which is a separate piece, all go together. Now when they're finally solved, let's take a look at just this piece here, because there's a bunch there that I can't give you right now because I don't have it. But I can go back and I can say, okay, well, I know that secant of theta is x over 5, and I know that tangent of theta is the square root of x squared minus 25 over 5. So this would be, 1/4 x over 5 cubed square root of x squared minus 25 or 5. Again, plus all of that extra stuff. And the idea here, and we're not going to finish this because I don't have the board space to finish it otherwise, and it would take a lot of time. But the principle is sound, that when you get to this point, when you finally finish the integration, you have to substitute back in. So, it all equals that plus, whatever, plus c. But it's the same process over and over. Once you get the integration down, which is usually some sort of trig integral, right? Some powers of trig or some blah, blah, blah. Once you get that, you plug back in for what you have, and that's really just, again, that's the process over and over and over.